And we're back in 9.2 where we're learning how to name and write formulas for ionic compounds. In this podcast, we're going to start addressing polyatomic ions and how they interact in ionic compounds. And the key here is understanding that polyatomic ions act as a single unit. You treat them as one, and everything else is the same as we've already learned in this section. For example, when you're dealing with sodium ions combining with the nitrate ions here in this first example, you're still going to crisscross the charges. You have a plus one here, you have a minus one here, so you're only going to need one sodium and one nitrate. So the formula will be NaNO3. One sodium, one nitrate. In the case of barium 2+ combining with a carbonate ion, which is CO3 2-, you're going to crisscross the charges and reduce. Well, if you have a 2+ and a 2-, you only need one of each. So it's simply going to be BaCO3. One barium, one carbonate. So notice the CO3 is functioning as one unit. You think of it as one unit. Now, the crisscross method still works when you're dealing with, down here, potassium combining with sulfate. The 1 will go with the sulfate. You only need one of those. Of course, you don't write the ones in. The 2 goes with the potassium, so you need 2 potassiums, K2, with 1 sulfate, SO4. Here's your 2 potassiums. Here's your 1 sulfate, SO4. Now, if you have to put a number out in front of the polyatomic ions or behind the polyatomic ions, you're going to have to include parentheses. In this example, you have iron 3+ combining with the chlorate ion ClO3 1-. The 1 will go with the iron. The 3 will go on the outside of the chlorate. So you have Fe1, but you don't write that. You have ClO3, there's the chlorate, but you need a 3 to go on the outside. Now you might say, well, there's already 3 there. No, that 3 stays with the oxygen always. You need to put a 3 with the entire chlorate. So to avoid confusion, we put parentheses around the polyatomic ion and then put the number on the outside, the subscript on the outside. So this formula will be Fe ClO3 in parentheses 3. Alright? What this is going to mean is that you're going to have only one iron, you're going to have 3 total chlorines, and 9 total oxygens. You distribute the 3. If you're counting up the individual atoms, you distribute the 3 across the parentheses. Going down to the next example. Copper 2+ combining with a phosphate ion. The 3 will go with the copper, the 2 will go with the phosphate. So you have Cu3. The phosphate is PO4, but you need to put a 2 behind it, so you put the PO4 in parentheses and then put the 2. So this formula is Cu3, PO4 in parentheses, 2. Looks like there's a lot going on in there, but all this is saying is that you need 2 of those phosphates to balance the charge of 3 of these coppers. Alright, so Cu3, PO4 in parentheses, 2. The same is true when you're working with a polyatomic cation like ammonium. The 1 will go with the chlorine, or chloride. The 1 will go with the ammonium. So you have 1 ammonium, which is NH4, and 1 chloride, which is Cl. And there you go. Okay, scrolling down. The 1, lost my pen there. There we go. NH4 plus NO3, 1-. The 1 from the ammonium will go with the nitrate. The 1 from the nitrate will go with the ammonium. So you have 1 ammonium and 1 nitrate. NH4, NO3. And finally, in this one, you have the +1 from the ammonium going behind the carbonate, the 2 going behind the ammonium. So once again, you have 2 ammoniums, which means you'll have to put the NH4 in parentheses, 2, and then you only need 1 carbonate, so it's CO3. So the formula for this would be NH4 in parentheses 2 CO3. All right. In the next podcast, we're going to show you how to name these ionic compounds with polyatomic ions in them.